if you have been working the Lyle problem, 7.2 and 7.3, there's nothing new in the Sisson problems. Okay? There's nothing new in the Sisson problems. What happens with the Sisson problems now is that they're just all mixed together into one section. All right? So, look on the Sisson 1 through 20 and pick 3 that you'd like to see work. Any 3 of those. 1 through 20, you pick any 3.
7.
Number 7. Okay, Sisson 7.4, number 7. Okay, pick another. Get 3. You get 3 that I'll work for you.
10.
10? All right, 10. What else? Anyone?
Number 19.
19. Okay. 7, 10, and 19. All right, we'll start off and just do them in order. 7, 10, and 19. Somebody's going to not have all their problems work from Sisson 7.4, and they've had a chance to ask for help. Okay, number 7. Negative, I'm going to put the negative in the numerator. I just like to go ahead and get the negative in the numerator. Square root of 48 sine x equals 1/8. All right. If you wanted to, you could take the reciprocal of both sides because it's a fraction equals a fraction. Fair enough? Or you might realize that if you make that a positive 1 and that a positive 1, and move the negative sign down here, then this denominator has to equal that denominator. Because both the numerators are what? 1. But some way, using some little algebra stuff, you get to this step. Now, I don't like the square root of 48. Somebody tell me why I don't like the square root of 48, because it will
Be imaginary.
won't be imaginary because the negative sign's out front, but if the negative sign was inside, it would be imaginary. But it's outside, so you've got to be careful there. It's irrational. Yeah, the Greeks didn't like irrational numbers either. But what's the deal with 48? It can be what? Simplified. Okay, does everybody agree that that's 16 times 3? What is the square root of 16? 4. So I get negative 4 squared root of 3 sine x equals 8. So sine x equals negative 8 over 4 square root of 3, which I can't believe I'm writing that step, but I am. So sine x equals negative 2 over the square root of 3. And at that point, I'm not happy. Because I keep thinking that I probably made a mistake. For it to be on my unit circle, it needs to be what? Square root of 3 over 2. So I quickly looked to see if maybe I made a mistake. And I didn't. But I did notice something about this. Please remember that anytime you're doing sine x or cosine x, it only works, you can only find results if the value is between negative 1 and what? 1. Negative 2 over 1 point something, because the square root of 3 is 1 point something, right? It doesn't fall in this interval. It doesn't fit. It doesn't give you a workable problem. So in this case, this one is empty set. Now, when he made out the problem and he put it in the book, Dr. Sisson, I think he really meant for it to work out to be negative square root of 3 over 2, and then afterwards realized it was wrong, but by then they were, just put in the answer key and put empty set. See, if he'd have put the reciprocal here, or he'd put equal 8 there, he would have make it work. But that one doesn't work. Empty step. Watch for this. See, that's not in your interval that works. when you take the sine or cosine of an angle, the results has to be between -1 and 1. Well, that's not. So it can't work. That's an empty set. That's a trick one. All right. Now, number 10. Is it equal 0?
Yeah.
Yes, it is. Okay, good. Equals 0. Any question about that one before it disappears from the board? Anyone? All right, number 10. Number 10. Since it's already factored, the key is, when I look at one that's factored, I get really excited as long as it equals 0. If it does not equal 0, these factors are not going to help you. Okay? But this one does equal 0. So I can set each factor equal to 0. If it didn't equal 0, you'd have to multiply it all out, make it equal 0, and refactor it, like you did in Algebra 2 with polynomials. Multiply it all out, refactor it with it equals 0. This one already equals 0. So what I will do, set that one equal to 0, and set that one equal to 0. I want to get tangent squared x is equal to 1 over 3. Please remember, you are taking the square root. So it could be positive or negative. Square root of 1 is 1, and then you've got your what? Square root of 3. This one, tangent squared x equals 3. The tangent of x is equal to positive or negative square root of 3. Now what do? You look at your what?
Unit circle.
Unit circle. Now, I'm going to let you tell me, okay, what are they? I think pi over 6 is one of them, isn't it? Pi over 6. How about pi over 3 is another one, but it's right. If you go around a circle and looking for both of them, you get pi over 3. You get 2/3 pi is 1. It works for one or the other one. I don't know which one. 5/6 pi. Since they're 1 over the square root of 3 or the square root of 3 and they're positive or negative, I know they're at the what? 30/60s, right? So I can kind of guess. 7/6 pi. 4/3 pi, 5/3 pi, and then 11/6 pi. That's all of what x would equal between 0 and 2 pi. And we want the solutions 0, 2 pi. And that's what I've got. And on the test or anything I give, it's always going to be from 0 to 2 pi. I'll make sure. Anyone got a question about that? Anyone? Going once. Going twice. Anyone got a question about that? Anything that's on the board, you got a question? I hope you're writing down everything I'm writing on the board, because when you try to turn in that packet and your packet's not complete, I'm going to laugh. How do you pass if you don't write down everything the teacher writes on the board? Because, Mr. Evans, you give everyone an A or B anyway. Yeah, I do make A's pretty easy to get this year, but still, write it down. Are you a senior? I can understand a senior being that lazy, but a junior that lazy?
Yeah, I've given up on school so this year. I got 3 weeks left, if I can just make it through it, I don't care if I don't have to pick up another.
See, you're honest, yeah. Just hold that pencil
High
over
school
the paper.
doesn't matter once you get to college.
That's right. You don't talk about your ACT scores anymore.
Yeah, I mean,
Yeah.
and once you get accepted, high school does not matter.
Well,
Unless you get, is it possible to get D accepted?
it's possible. It's possible to lose scholarship money. Yeah. MACK'S. Yeah, it's possible to lose scholarship money. I've never heard of anybody losing their acceptance letter.
So as long as I pass, I'm completely fine.
You're going to make it. Yeah. And you may only need to pass English to graduate, right?
No, I got past 6 different classes,
okay.
and it's difficult.
Yeah, I'll probably put it up on there for my class just for fun.
That would literally ruin my life.
Okay. Now,
Say no to.
here's what I want to talk to you about. And this is not required for me, but this is required probably for your future. If you look at the answers in the Sisson book, that's not what he gives. I'm going to show you what he writes. He writes x equals pi over 6 plus, and what do you add to pi over 6 to get pi over 3? You add what? Okay, I'm going to write these as, I'm going to write that as 2, 6. Is that okay? I'm going to write that as what? 4, 6. I'm going to write that as 5, 6, 7, 6, 8, 6. Yeah, 8, 6, and 10, 6. What I'm trying to do is I'm trying to figure out the pattern of what's happening here. 11, 6 pi. Okay, and then it's 1, 6, right? So it goes 1, 2, then what? 4, 5. Okay, if I see the 1, 6 right here, and see the 4, 6, does everybody agree I added a half pi to get to there? And does everybody agree that I added a half pi to get to here? And I added a half pi to get to there? So what he would say is he puts an n and then pi over 2. And what he's saying is you started off with pi over 6 when n is 0, if n equals 0. And then if equals 1, you added pi over 2 one time. If n is equal to 2, you added pi over 2 how many times? 2. If n is 3, then you added pi over 2 how many times? 3. Is that okay? Get the idea? And so that takes care of those. Then he says, you'll look, it'll also say that it equals pi over 3 plus n, and then you got to know what did he add to get from here to here. He added half a pi again. And that's how it would be written in Sisson. Now, the n is always an integer. Okay? The n can be negative. What's he doing? He's giving you all the solutions from negative infinity to positive infinity. He's not just giving you the ones from 0 to 2 pi. He's giving you what? All solutions. The entire spectrum. If you want to write them like that, I won't complain. The only thing I have to have on my test is everything between what? 0 and 2 pi. But that's how they're written in his book. Now, if you're trying to find out if your answers match his, well, you put a 0 in there, you get the very first one. You put a 1 in there, you get the next one that's circled. You put a 2 in there, you get the next one that's circled. Put a 3 in there, you get the next one that's circled. Put a 0 here, you get pi over 3. Then put a 1 in here, and you get 5, 6. Put a 2 in there, you get 4/3. Put a 3 in there, and you get the one out here on the end, 11, 6. Fair enough? But that's how he writes them. And I'm not going to require you to do that, but I think it's good for you to see. And to understand why he does it, because that covers what? From everything. All right? Now, I can't just do this. I have to make a list out and think about it. All right? I have to make a list out and work it out. A lot of people, they get so good at it, they go, oh yeah, it's going to be, because this is how much you're adding every time. That's the part that you got to work out. Somebody said, well, can't you just add 2 pi every time? Well, yeah, but then you'd have to write down all of those and put 2 pi after it, and that would be really messy. We happy with number 10? Learned a little extra information, didn't we? Oh, she's at least opening her notebook to a page that has writing on it. What's your grade in here? Are you happy with that B? Do you want a C?
I wrote some stuff down.
Okay. Because you know, this right here is going to be the letter grade crusher right here.
Yeah, no, there's no way I can do all that, Mr. Evans.
Then you better do the packet so that you at least have a 50 out of 100 going into the test.
Well, I mean, if you would think if you could do the packet, then you could probably do the test.
You got a good chance, but I'll be honest. On this, there will be people that are going to turn in a perfect packet and fail the test, but at least they were willing to get their friend and buy them pizza so that their friend would show them how to work all the problems in the packet.
Yeah.
And let them copy down their work for, you know, pizza or steak. I mean, this might be worth steak here, because we're talking a letter grade.
Right.
And I doubt anybody's going to raise their grade with this one, but a lot of people.
Okay, say,
Oh, and by the way, seniors, who in here is a senior? The good news is I'm going to count this as y'all's final exam, too.
oh my God, thank you so much. Oh my God. What?
Now we'll count this as your final. The packet and that count as your final exam. Plus a few little problems we'll throw in, but this is your final exam. 19. Cotangent 2x. And if y'all don't mind, I'm going to skip a step and we'll go ahead and make that equal negative square root of 3. Except, do I know a lot about cotangent? I just know it says reciprocal of what? Tangent. So I'm going to do tangent 2x equals negative 1 over square root of 3. And this is one where I got to turn it into theta. Anytime you got a number in front of the x, it's better just turn it into theta. Write down what you're doing. Theta equals 2x. And then tangent theta equals negative 1 over square root of 3. And then give me a list of the theta answers. Pi over no. 5, 6 pi is one. What's the other one? If you go around the circle, 5, 6 pi, 11. 11, 6 pi. But what does that 2 tell me? I can't go around the circle just once. I got to go around the circle twice. So it's going to be 12, 6 pi. So I add 12, 6 to that, I get 17, 6. I add 12, 6 to that, I get 23, 6. But that's what theta equals. I need to know what x equals. Now, if you wrote this one down, like I told you, then it's pretty easy to figure out what x equals, because x equals what? Half of theta. So you go down here and just take a half of all those. 5 twelfths pi, 11 twelfths pi,
17 12 pi.
17, yes sir.
And 23 12 pi.
And do you notice you're getting real close to 2 pi right there, 23 over 12? Because 24 over 12 would be what? 2 pi. There's what Mr. Evans wants to see. Now, I think if you were to look at Sisson text, you would see that he just put 5 twelfths pi and realize that you're adding 6 twelfths, 6 twelfths, 6 twelfths. So he did 5 twelfths plus n pi, 6 twelfths, which reduces to what? Pi over 2. And that's what Sisson would put as your x equals. I'll take either answer. 0 to 2 pi makes me happy. If I can get you out of here knowing how to get 0 to 2 pi. If I can get half of you out here knowing how to solve a trig equation. The half of you that are not majoring in, unless you're majoring in physics, Well, okay, yeah, because you got to know trig in order to take Calc 1. You got to take Calc 1 to major in anything except English, history, art, all those non-paying fields. You don't have to take Calc 1. All the things that pay, you have to take science classes. Does everybody hear that? Yeah, all the things that pay require you to take science classes. And all science classes require you to take at least Calc 1. Business majors can pay, but then you have to take business calc. And it doesn't have trig in it, but it's got E and natural log in it. So, there you go. Now, every class today, I am making a video of what I've worked in class to help you. I worked number 73 this morning in first hour. So don't pick 73. But I will work one other problem from anywhere on the assignment. If you look anywhere on the assignment and you see a problem that you would like to see worked, I will work it. But don't pick 73 because it's already going to be recorded from the other class. But you know, I don't want to work 73 every class because it's already recorded. Pick one. Be brave, be bold, pick one. Pick what you want to pick from the ones that I assigned. The reason I didn't assign some of them is because they don't work out on your unit circle. Everything I'm doing is on that unit circle. Let me scroll up on this a little bit, see if some of you might feel to look better. Scroll up. Don't let me fall on you or step on that. I don't know. You can go on down the page if you want, but pick one.
25.
25. I will, let's see, on 62, I think you have to square both sides to work 62. I will give you that hint. On 62, I think you have to square both sides. 25. Okay. 25. Point 0 5 sine cube x minus, no, yeah, I'm going to go ahead and bring it over and make it equal 0. Minus 0.1 sine x equals 0. I know it needs to equal 0 because I got squares or cubes. Anytime you got x squared or x cubed, you know you got to need to make it equal 0 and then do what? Factor. Right? Here's the problem. That is tens, hundreds. That's 5 over 100. So that's really just what? 1/20th. I like that a lot better. And that's just 1/10. Is that okay? Now, at this point, if you wanted to, does everybody agree you can multiply everything by 20 and totally eliminate the fractions?
Yes.
Yeah, just multiply everything by 20. Now you probably see that you need to factor out what? Sine x. Everybody ready now to factor out sine x? But you see how you do not want to try to work this with decimals. If you try to work this with decimals, are there any decimals on your unit circle? Then you're not going to find any decimals. Factor out sine x. Sine squared x minus 2 equals 0. Sine x equals 0. Sine x equals the positive or negative square root of 2. That number is bigger than 1 or smaller than negative 1, isn't it? That's an empty setter right there, but then you gotta work out this part. 0, and then where else? Pi. And if you put 2 pi, Mr. Evans wouldn't mark it wrong, but 0 and pi. This one, nope, no help. Now, if I were to get that, and I was working these, I'm gonna be honest, I would sure go back and check it real close, because if that was supposed to be 1 over the square root of 2, it would work, wouldn't it? See? So anytime I get something like that, I have to go back and check it real close and make sure I didn't lose a reciprocal or didn't, make a little algebra mistake early on. Because I sure do, think that, if that would have been a 2 here, and that would have been a 1 here, then I'd have got something that helped me there, but it's not. So anytime you get something that's close to the unit circle but not, look at it, make sure you didn't make a little error right away. I was working a problem in the engineering class this morning, and it's got a ton of trig in it. And every time I would see 2, square root of 3, or square root of 2, I was happy. Because I knew those were going to eventually be where? Unit circle. Every time I got a 7, I knew that couldn't be where? Unit circle. If I got 1 over the square root of 7, and if you're working textbook problems, in the calculus textbook, there are going to be things that work out to the unit circle. So I'd always kind of go back and check my steps anytime I got something that didn't look like it was going to be on the unit circle. There you go. Now, I strongly suggest you spend today, you got 25 minutes, I suggest you work some problems. Now, if you don't have the packet done,